Hello everyone! Welcome to our channel. Stay tuned and you will learn mathematics in just few minutes. In this video lesson, we will illustrate how probability distribution or probability mass function of a discrete random variable is constructed. Let us begin with the tossing of coins. First example, tossing of two coins. Suppose two coins are tossed. Let x be the random variable representing the number of tails that occur. Find the probability of each of the values of the random variable x. We will use capital letter H to represent the head that may come out and T for the tail. First, construct a table and list down all the possible outcomes in tossing two coins. So here are the possible outcomes. The first coin may be a tail and the second coin may be a tail also. Another possible outcome, the first coin is a tail and the second is a head. Or the first coin is a head and the second is a tail. It could also be a head and a head. These are all the possible outcomes in tossing two coins. Let's go back with the problem. It says here that let x be the random variable representing the number of tails that occur. So we are going to count the number of tails occurred in each outcome. The first outcome has two tails, the second has one, the third has one, and the fourth has zero or no tails occurred. Now list down the values of a random variable x. Take note, t and h are not random variables. They are just representations of heads and tails that may come out. The values of our random variables are 2, 1, and 0. Next, identify the frequency of each values of the random variable. For 2, we have only 1. 1 has 2, and 0 has 1. Now get the total frequency. We have 4. Since we have 4 possible outcomes, therefore, we have 4 total frequencies. Lastly, determine the probability distribution of the random variable x. To do that, just take the frequency of the first value, which is 1, over the total frequency 4. So we have 1/4. Second, we have 2 over 4, so the probability is 2/4 or 1/2. And the third and last, 1 over 4, we have 1/4. To check if the probability distribution is correct, just add all the probabilities. We have 4 over 4 or 1. Since it is equal to 1, then our probability distribution is correct. Second example, tossing of 3 coins. Suppose 3 coins are tossed. Let x be the random variable representing the number of heads that occur. Find the probability of each of the values of the random variable x. This time, we will focus on the number of heads. Here are the possible outcomes. The first coin is head, the second is head, and the third is also a head. Another possible outcome, head, head, and tail. Or it could be H, T, and H, T, H, and H, T, T, and H, T, H, and T, H, T, and T, and T, T, and another T. These are all the possible outcomes if we are going to toss 3 coins. Now, identify the number of heads in each outcome. We have 3, 2, 2, 2, 1, 1, 1, and 0. Then write the values of the random variables. These are 3, 2, 1, and 0. Next, determine the frequency. 3 has 1, 2 has 3, 1 has 3, 0 has 1. And the total frequency is 8 because there are 8 possible outcomes. Lastly, complete the probability distribution. We have 1/8, 3/8, 3/8, and 1/8. Last example, we are going to solve this problem. A meeting of consuls was attended by 4 Americans and 2 Filipinos. If 3 consuls were selected at random, construct the probability distribution of the random variable f representing the number of Filipinos. Again, first step. List down all the possible outcomes on selecting only 3 consuls. So here are the possible outcomes. Filipino, Filipino, American. Take note, we cannot have 3 Filipinos because there are only 2 of them. Next, Filipino, American, Filipino, AFF. We also have AAF, AFA, FAA, and AAA. Second step. Identify the number of Filipinos that occur in each outcome. We have 2, 2, 2, 1, 1, 1, and 0. Third step. Write the values of the random variables. We have 2, 1, and 0. Fourth step. Determine the frequency. The first one is 3, the second is 3, and the third is 1. That will give us a total of 7. And the fifth step, the probability distribution. We have 3 sevenths, 3 sevenths, and 1 seventh. Before we end this video lesson, these are the things that we need to remember. Number 1. The probability of each value of the random variable must be greater or equal to 0 but less than or equal to 1. And number 2, the sum of the probabilities must be equal to 1.